Alright, this is 7-1 confidence intervals. This is the lecture portion of it. Alright, now, we're going to learn a couple of different confidence intervals. The first one is going to be a confidence interval about the mean using a z-value. In 7-2, we're going to use a t-value. We'll have another lecture for that. And then when we do 7-3, we're going to be estimating using a proportions. But for this one, we need a few things. First off, sigma needs to be known. Now, if sigma is not known, you can still use this as long as the sample size is bigger than 30. And if you don't know why that's important, look back at the central limit theorem, because as we take estimates of the mean of the samples and the sample size increases, it'll become normal. So when the sample size is bigger than 30, we can use that. Now, if your sampling isn't bigger than 30, as long as it already comes from a normal distribution, then we can also use it. So I'm just going to read off what I have here on the slide. Sigma is known, and either the sample size is greater than 30, in other words, n is greater than or equal to 30, or the sample size is less than 30, but the distribution is normal. So if you have sigma, you're good. If your sample size is bigger than 30, you're also good with or without sigma. If your sample size is less than 30, you don't have sigma, but the distribution is normal, then we can use the z information. Now, flipping slides. Alright, what is a confidence interval? Well, it's two words slapped together like math does a lot, and we have to know what each of these is. How confident are you? And what we're trying to do is capture the true mean of the proportion. We're trying to capture mu, and I'm pointing at an inequality right here, where we have the lower end of the inequality and the upper end of the inequality. Oh, and that gives us an interval. That gives us a range of values that the true mean can fall in between. Now, back to confidence. We're going to be 90% confident, 95% confident, 98% confident. Each of these is going to give us an alpha level. The alpha is just 100% minus the 90%. So in other words, for 90% confidence, alpha would equal 10%, or 0.1. For a confidence level of 95, our alpha, and this is not an X I'm making, it's an alpha, lowercase Greek letter alpha, would be 0.05% for the 95. For the 98 confidence, our alpha level would be 2%, because if I add it, I'd get 100%. Sorry for the little goof up there. Okay, so now, when you have a range, so that's the confidence level, and you see how we're getting the alpha. I will talk more about this in 2 seconds, because it's important for z alpha over 2. The interval is a range of values, so we have to have a lower end of the range, that's the beginning of my inequality, and we have an upper part of the range, that's our maximum, which is the right side of the inequality. Now, what we do is, and I'm just going to condense it down to this, x bar, which is your guess, it's your point estimate, plus or minus z alpha over 2 times sigma divided by the square root of n. More on this in a second. The right side of that inequality, the z alpha over 2 sigma divided by square root of n, that is the margin of error. Okay, that's how far away from the mean, your point estimate, your x bar, you are going to be when you set up your inequality. See, we have the lower end where we subtracted from the mean, and we have the upper part of the inequality where we added to the mean, and in the middle we have mu. Okay, now the one question that everybody always has is about z alpha over 2. And here's what z alpha over 2 is. Z alpha over 2 is a different type of notation than what we've had before. Really, it's just going to be your inverse z value, or inverse norm, sorry, let's match the calculator, inverse norm of your alpha level divided by 2, so if it's 10% for a 90% confidence level, then it'd be 5% there, so 0.5, comma 0, comma 1, because we're in the z world, not in whatever we're working in. This is what the inverse norm is for, and that's what z alpha over 2 is. It's just inverse norm. The area is the alpha over 2, and it's 0 and 1, so we get a z value out. Now, you do got to watch out for this, because a lot of the times you're going to be sticking in a very tiny alpha, and this will be a number that is negative. But since you're adding and subtracting for the plus and minus for x bar plus or minus z alpha over 2 times sigma over the square root of n, if that's negative, then you have a negative minus a negative, which is positive, and a positive plus a negative, which is a negative. So don't get too hung up on the sign there. Just remember we're going to be getting this. Now, the next slide I'm going to do an example, but it's going to be practical, and we're just going to use the calculator. But if you had to calculate it by hand, here's how you would do it. Similarly, if they ask what is the error, that's how you can calculate the